Hi, have you ever enjoyed a live concert in an auditorium? The loudspeakers kept at different locations in the hall bring the music to life. And we enjoy it, right? Have you ever stood in front of a loudspeaker and felt the vibrations? Did you ever wonder how you are able to hear the same sound from a loudspeaker as it is produced by a speaker at the microphone? Let's see how. The functioning of a loudspeaker is opposite to that of a microphone. It receives electrical signals and converts them into sound waves. Vibrating bodies produce sound. If the frequency of vibrations is between 20 Hz and 20,000 Hz, then we can hear the sound. A loudspeaker basically consists of a permanent magnet surrounding an electromagnet, which is attached to a membrane or cone. At the front of a loudspeaker is a fabric, plastic, or paper cone, also known as a diaphragm. This flexible cone or diaphragm is attached at its wide end to a suspension. The suspension is a rim of flexible material that allows the cone to move and is attached to a frame called the basket. The narrow end of the cone is connected to the voice coil. The coil is also attached to the basket by a ring of flexible material, which holds the coil in position but allows it to move freely back and forth. The voice coil is basically an electromagnet. A coil of wire is wrapped around a magnetic material. When current passes through this coil, the material becomes a magnet with its ends behaving like the north and south poles. The strength of the magnetic field depends on the strength of the current in the coil. The polarity of the electromagnet depends on the direction of the current. When the electric current passing through the voice coil changes its direction, the polarity of the electromagnet also changes. There are two wires to every speaker. When the loudspeaker is hooked to a stereo, electrical signals are fed through the speaker cables into the coil. These electrical signals constantly reverse the direction of the electric current in the coil. This alternating current causes the polarity of the electromagnet to reverse itself. This happens many times in a second. The voice coil is positioned inside a permanent magnet. As the electrical signals pass through the coil, the polarity of the electromagnet changes, either attracting it to or repelling it from the permanent magnet. This pushes the voice coil back and forth rapidly. When the coil is in motion, it also pushes and pulls the cone. This sets up vibrations in the air in front of the speaker, thereby creating sound waves of the same frequency. The frequency and amplitude of the sound waves so generated by the loudspeaker depends on the rate at which and the distance through which the voice coil moves. This, in turn, depends on the frequency and strength of the electric current passing through the coil.